Alright, this lecture is on the population standard deviation. Again, remember the standard deviation is how spread out your data is. When you're talking about a population, we use parameters. So Greek letters. The Greek letters for the population standard deviation is sigma. Alright, again, there's going to be two formulas that we can use to calculate this. The defining formula and the computing formula. We're going to use the computing formula because it's really easy. Okay, so we're given some data. This is the number of months a testing site saw that paint lasted, outdoor paint lasted, and they only did 6 paints, so this is a population: 35, 45, 30, 35, 40, and 25. All of these are how long it lasted, how many months. Alright, the formula is the square root of the summation of x squared, which we saw in the sample standard deviation, divided by n, which is our population size, minus mu squared. Remember that mu is the population mean. So I've already calculated the population mean over here. That's mu equals the summation of x divided by n. Summation of x means we add up our first row of numbers here. Should get 210 divided by 6 equals 35. Alright, so what we do, first we need summation of x squared. Remember, just like sample standard deviation, we square each of these first row of numbers. So 35 times 35 is 1,225. Then, once we square all the numbers, we add them up. When you add them up, you should get 7,600. And there are 6 numbers, minus the mean squared. Now we're ready to simplify. Well, these are two different terms, so what we can do is just do each of those, such as 7,600 divided by 6 is 1,266.6667. Remember to go ahead and round it to 4 decimal places. Minus 35 squared, which is 1,225. Now we're ready to subtract. When we subtract, we get 41.6667. Finally, just take the square root to 4 decimal places, and you should get 6.4550. This concludes, and this is, the population standard deviation. The next lecture, next presentation, will be on how to interpret the standard deviations.